Hello friends, so myself Shruti Dhanavde. So today we are going to discuss on the topic index properties in geotechnical engineering. So this presentation dwells into the essential index properties that define soil characteristics crucial for understanding soil behavior in engineering applications. So today here we are going to see total six index properties. So the first is So here it is the definition of water content. So water content is the ratio of mass of water to the mass of dry soil, and it is expressed in percentage. So here is the formula derived. That is here WW is the mass of water to the mass of dry soil into 100. Next is the soil dryness indicator. So when W is equal to 0, it indicates that soil is completely dry. And what is the impact on soil properties? So water content significantly affects the consistency, strength, and compaction of the soil. Next, so how we are going to determine the water content in materials. That is, we are going to explore here methods and practical applications of water content. So first method to determine the water content is oven dry method. So this is the standard technique for determining the water content through controlled heating. Next, it is usually this oven dry method is usually used in laboratory method. So this is a laboratory method. Next is rapid moisturometer, a field method allowing quick measurement of water content for immediate results. Now these are the these are the applications, practical applications. First is the compaction control. So this ensures the optimal moisture levels for effective soil compaction in construction. Stability analysis evaluates how moisture content affects the stability of structures and materials. And the next is permeability assessment. So it determines how water movement through soil is influenced by its moisture content. The second index property is the specific gravity. So first definition. So it is the ratio of unit weight of soil to the unit weight of water. So what is the importance in calculation? So this is essential for void ratio and unit weight calculation in geotechnical engineering. So these are the ranges we are going to see in the specific gravity ranges. So these are the typical values that range from 2.65 to 2.68. So this is specifying that this is the gravel. If it is a sand or silt, so common values are between 2.67 and 2.70. So this is reflecting moderate density. Specific gravity of clay, it typically ranges from 2.70 to 2.80. So this is indicating its compact nature. And for organic clay, it has the values which is less than 2. This is indicating a lower density. Next, determining the specific gravity of soil. So this can be determined by using the two methods, that is pycnometer method and density bottle method. So these both methods are used in laboratory. So pycnometer is used mainly for granular soils, that is uh, sand or gravels, to measure the specific gravity accurately. And density bottle method is ideal for fine soils. This method provides precise specific gravity readings. And the next engineering properties, that is index properties, the field density of soil. So field density or in situ density measures the soil density in its natural uncompacted state. Role in compaction control. So this is used to ensure proper compaction during construction, affecting project quality and safety. Next, how it determines the bearing capacity. So field density is crucial for accessing the load bearing capacity of soil, impacting structural integrity. Next, how it influences the settlement prediction. So accurate field density measurements help predict possible settlements in structures essential for design. So this we seen about the field density of soil. Next, we are going to see the methods. Which are the methods we can perform for field density? So this is there are two methods, that is core cutter method and sand replacement method. So this method is ideal for cohesive soils and involves cutting a core sample. Cohesive soils means the clay or slate which attract the particles, finer particles. Next method is sand replacement method. So this is used for a granular soil, and this method involves replacing soil with sand to measure the density. It is also known as the field method. This is field method. Next, quality control importance. So it is determining soil density is crucial for ensuring construction quality and stability. Then the next index property is the particle size distribution. So it describes the distribution of soil particle sizes essential for soil characterization. Then how it influences on soil properties. So fundamental characteristics, it affects permeability, strength and compressibility of soil. Next, how classification of soil types. So the soil is classified. So soil into classifies into categories such as gravel, sand, slate and clay. Then what is the importance in engineering? So it is crucial for design and construction decisions, ensuring stability and performance of structure. Then how it impact on environmental factors. So affects water retention, root penetration, and ecological interaction in soil environments. So this we seen about the vertical size distribution. Then what are the methods for analyzing soil particle size? So there are usually soil particle is distributed into two types, that is coarse grain and fine grain. So for coarse grain, mechanical sieve analysis method is performed for analyzing the coarse soil to determine particle size distribution. And for fine grain soils, hydrometer or pipette method analysis is done. So next we are going to see the types of curves. So these are the three types of curves: well graded curve, uniformly graded curve, and gap graded curve. So well graded curve represents a diverse range of particle sizes, enhancing stability and strength in the soil. So these types of curves are drawn on semi-logarithm graph. Then second curve is uniformly graded curve. So uniformly graded curve is usually indicated in S line. So it indicates a narrow range of particle size, potentially leading to a lower stability. And third type of curve is gap graded curve. So this is showing the missing particle sizes which can affect soil behavior and stability. So these two are the methods and these are the types of curves in the particle size distribution where we can determine which type of particle size it is. Then the next index property is consistency limit in soil. So first definition, consistency limit are the water content levels where soil transits between states. That when soil changes from one state to another, it is known as consistency limit. So there are three types of consistency limit: liquid limit, plastic limit, and shrinkage limit. So liquid limit is the water content at which soil changes from plastic to liquid state. The next is plastic limit. So plastic limit is the water content where soil transitions from semi-solid to plastic state. Shrinkage limit. Shrinkage limit is the water content at which soil changes from solid to semi-solid state. So what is its significance? So significance of consistency limit. So these limits indicates the soil consistency, plasticity, crucial for engineering. So consistency and plasticity is known. So here plasticity is again, so plasticity index can be calculated as liquid limit minus plastic limit. So this is indicating the soil behavior. Next is the Atterberg limit significance. So Atterberg is the only one who who classified the consistency limit. So these limits help classify the soil using IS and USCS guiding the engineering properties. IS is the Indian Standard Classification System. So usually we use IS only. Then how to predict the value of plasticity index. So plasticity index predicts the soil shrinkage, swelling, and strength characteristics. So these three types are known in the plasticity index, that it predicts the soil shrinkage, swelling, and strength characteristics. Engineering properties, that is the index property, is the relative density in soil. This is the last index property which we are going to see. So relative density indicates the compactness of cohesion-less soil, like sand and gravel. Cohesion soils are what? Cohesion-less sand and gravels. What is the importance of relative density? So it helps in access the soil behavior under various loading conditions, and it is crucial for engineering applications. So what is the formula for relative density? So relative density is nothing but E max minus E divided by E max minus E minimum into 100. Defines the relative density calculation. So where E is the void ratio. E represents the natural void ratio indicating the amount of void space in the soil. And E max and E minimum indicate the loosest and densest state of soil critical for relative density calculations. Next, we are going to understanding the relative density in the granular soil. So now here we are going to see the ranges of different soil particles, from where to where it will range and what it signifies. So indicators of strength and compressibility. So relative density serves as a crucial measures of granular soil's strength and compressibility impacting the stability. Classification of relative density. So granular soils are classified into 5 categories based on the relative density percentages indicating their compactness. So first is very loose, that is soils with the relative density less than 15%. So less than 15% are categorized as a very loose, indicating the low strength and high compressibility. So it is indicating low strength but high compressibility. Loose sand, that is 15 to 35%. So loose soils with the relative density between 15 and 35% display moderate strength. They are displaying the moderate strength but are still compressible under the stress. Medium dense soil. So this is 35 to 65%. So medium dense soils ranging from 35 to 65% provide a balance of strength and compressibility. It is suitable for various applications. Dense soil 65 to 90%. Dense soils have relative density between 65 to 90%, offering high strength and lower compressibility. So here we can see the comparison we can do, that is very loose and dense soil. Very loose soil is having the low strength and high compressibility, but dense soil is having high strength but lower compressibility under the load. Very dense. So soils exceeding 90% relative density are considering very dense, providing a maximum strength and minimal compressibility. Okay, so here we seen about the 6 index engineering properties in geotechnical engineering. So, so I'll end my presentation here. Thank you, everyone.